Good morning, everybody. Yesterday we have seen whatever the topics we have covered as a part of Unit 3, Network Layer. We have seen various topics like, I will just rewind whatever topics we have covered in the last classes so that you will have an idea that how we are going, how we are moving from the basic stages to the uh, advanced stages. So we are actually studying the network layer. The very responsibility of network layer is to find a best route, that is the optimal path, and transport a packet from source to destination. This is the main uh, functionality of network layer. So in order to achieve this, it is accomplishing various responsibilities. It is going through many phases and it is completing it. So in the very first, it is going to find the route. There are different routes, and it is going to compare the optimal path. From the optimal path, it is going to establish connection. May it be a virtual circuit, or maybe may it be a broadcast. Then it is sending the packets. Sometimes packet go in stream, in line, or in other method, the packets may move in different direction and they will reach a destination in the order or in the without order, and they will be reorganized at the destination. So what we have studied in the last classes, store and forward packet switching. So how it is doing, how a packet is sent from source to destination by passing through various nodes, and it is implemented through connectionless or connection oriented service. In order to study connection we have studied in the last class, and we have also studied various routing algorithms. The routing algorithm is meant for finding a best route. Okay, we have categorized routing algorithms into two categories: non-adaptive and adaptive routing algorithm. And we have seen the different routing algorithms like shortest path routing, distance vector routing, link state routing, hierarchical routing, broadcast routing, multicast routing. These are the routing algorithms we have seen as a part of your syllabus. Now we will concentrate on the topic called congestion control. Okay, when there are many many nodes participating in the network, it is obvious that, okay, if a route is shared among the many nodes, it is obvious that route will face what do you call difficulty in passing a packet from source to destination. That difficulty we call it as a congestion. If a same route is what you call shared by many packets, there will be a congestion in the network. Today we'll see how network layer is responsible for controlling the congestion and what are the different techniques we have. It is adapting to control it. We have seen in the last class. Okay, just I am going to recapture that what we have done. So what we have done as a part of, so congestion control is a responsibility of two layers, that is network layer at somewhat congestion control is done at network layer, and somewhat congestion control is also done at a transport layer. So we are studying congestion control at a network layer. So we are having 5 approaches to control the congestion. We have seen network provisioning, traffic aware routing, admission control, traffic throttling, and load shedding. These are the 5 different approaches on the varying scale like this. Okay, uh, we are going to implement these 5 techniques in order to have congestion control. We have seen network provisioning is always not possible to have more number of resources, only two things we can do: either increase the resource or decrease the load. Okay, to control the congestion. So in our increasing the resource means you have to provide as many resources are enough to control the congestion. That is not possible because sometime or other time all resources cannot be used. They will be idle. So it is a cost effective. And parallelly, we cannot decrease the load because every node wants to participate in the network. They want to transport a packet. So definitely we should facilitate, we should give service to all the packets. So we cannot do both things. So what we are doing, we are following some somewhat different techniques. Okay, traffic aware routing, admission control, and traffic throttling, by which we are going to control the congestion in the network layer. So this is what we have studied in the last class. Okay. So today we are going to see what you call quality of service. So how quality of service is provided by the network layer. So quality of service means again it is some way or other way it is related to congestion also. Quality of service is directly referring to how good your packets are transported to the destination, in what time they are transported. Okay. Then how do you measure? How do you measure quality of service of any layer, any network layer or transport layer, or any communication it is happening? Then any communication from two nodes, if it is taking place, how do you measure quality of service? So there are a few parameters by which we are going to mention the quality of service. That is bandwidth, utilization of bandwidth, how a particular node is utilizing the bandwidth, whether it is optimally used or whether it is not being used and we have paid much amount for to take the bandwidth, and how much delay it is there, and what is the jitter we are having, and what is the packet loss. uh, when you are sending packet from source to destination, what is the packet loss you are having? With these four parameters, we are going to measure the quality of service. So, to provide good quality of service to network layer, so we should have for these are the following six parameters. If we take application requirement, traffic shaping, packet scheduling, admission control, integrated services, differentiated services. If we are going to follow, then definitely we are going to have good quality of service for any node that is participating in the network. So as I know, a stream of packets from source to destination, which are going, we call it as a flow. So the flow we are calculating using bandwidth, delay, jitter, and loss. Okay. So in the last class we have seen what is bandwidth, what is delay, what is jitter. Okay, and what is packet loss. All that we have seen, and we have also seen what are the different requirements of applications. So once again, I'll repeat this four parameters. So bandwidth is the root what is used by any node. Okay, it is varying. It is varying if you take it a normal email or audio or any other form. It is varying. So how it is varying? You see here. Um so bandwidth for email, very less bandwidth is required. Okay, when it is file sharing, high bandwidth is required. When it is video conferencing, high bandwidth is required. It means you should have a good bandwidth so that you will be having comfortable video conferencing. It means depending upon application what you are using, you must have the bandwidth. Okay, so for email, if you are having high bandwidth, it is wastage of bandwidth. For video conferencing, if you are taking low bandwidth, then you cannot conduct any video conferencing. And if you want to talk on video, If you are having very low or medium bandwidth, then you cannot participate in video calling. So likewise, depending upon the application requirement, you must have a bandwidth, and you are having a delay. So, and in some cases, delays are not permitted. Let us take the audio and video you are playing together. If they are not parallelly playing together, then you cannot understand. It means video is played. If it is playing a little forward, audio is coming back. Then you cannot uh, correlate what audio it is going and what video it is displayed. So in such cases, you should have a minimum delay, very minimum delay. Let us take email you are having. Less delay is required. It do not take much time. So likewise, depending upon the application requirement, you will be having delay and bandwidth. So the jitter, you see, jitter is variation in the delay or packet arrival. Some packets arrive fast, some packets arrive very slow. So jitter should be constant. Jitter should be constant if it is specifically you are playing the video or audio. So these are the four parameters, and we have also seen what is traffic shaping. We are coming across three different. We are coming across three different terminologies here. You keep it here. Um, Traffic shaping, traffic throttling. You see here when we have studied. You see here, traffic aware routing is one, traffic throttling, and that one is traffic. Uh, what do you, what is it? Traffic throttling, and now what we are having, traffic shaping. So three are different terminologies. Okay, traffic aware routing means if you want to participate in the communication, you see you have to find out which node is busy and which node is free. Depending upon that, you can participate in the network. That is traffic aware routing. And what is traffic throttling? You are going to identify which node is causing the which node is responsible for what you call congestion. You are going to find out that node. It means one or two particular nodes will be continuously injecting packets into the network, so that due to those nodes only, this entire network is facing with the congestion. So you are going to find out which node is that, which node is causing the congestion to the network. You are going to find out. That technique we are calling as traffic throttling. So what you are going to do in this, you are going to find out such node which is causing the congestion. Then you are going to explicitly inform, or via message you are going to inform that stop injecting many packets into the network. That is one way. Or otherwise, you send minimal packets into the network. So with this, what will happen? So the node which is causing the congestion, okay, it will send as few as many packets required to send with somewhat lesser speed. So that is traffic throttling. So this is again a different terminology, traffic shaping. So traffic shaping is a technique for regulating the average rate and burstiness of flow of data that enters the network. Again, traffic shaping is nothing but, so nodes will be having many packets to send into the network, but the network will allow only few packets to participate in the communication. It will not allow as many packets as sent by the any network. That is called traffic shaping. We are having two techniques we have studied in the last class, leaky bucket and token bucket. You see here, leaky bucket, it means uh, it is going to at any node or any processor or at any hub, the network administrator will receive all the packets, whatever the capacity it is having, we call it as a buffer, and it is going to release at a constant rate. At constant rate, this rate will be decided again how many packets, number of packets, it will be decided, and it will be released into the network. Okay. There was an interruption in between. Okay. We have seen this in the last class, the leaky bucket algorithm we have seen. You see here, at a host computer, all the packets are arrived. It will store the packets, whatever the capacity it is having. It means whatever the buffer capacity it is having, it will store all the packets which are received from the different nodes, uh, which they wanted to send to any destination. So after that, what it will do, it will inject those packets into the network at a particular rate, so that it will understand the network. It will do not cause any congestion. So another technique we are having, token bucket algorithm. In the same way, what it is doing, it is going to store all the packets into the buffer, then it is going to release at a varying number of what do you call rate at which packets are sent into the network. It means sometimes 5 packets are sent, sometimes 10 packets are sent, depending upon congestion of the traffic it is going to send. So here what is given, whichever node has entered into the network, those that node will be given what you call some token, maybe entry time or whatever, and those packets are sent into the network. This is the token bucket and leaky bucket. Using this, we are going to control the uh, congestion, and we will be having good quality of service. So apart from that, we can also implement packet scheduling, whatever we have studied in operating system. Same kind of scheduling algorithm we are going to use uh, in order to what do you call allocate a bandwidth, buffer space, and CPU cycle to the different nodes. So we are going to use what do you call first in first out. We call it as first come first serve, uh, to allow bandwidth to any node or buffer space to any node or CPU cycle. If there are any computations at any intermediate nodes, those CPU cycles are given. And this is the admission control we are having, same as what admission control we have studied in the uh, packet congestion control mechanism. So this is what I wanted to